this What's New mini-series featuring SOLIDWORKS simulation. Today we'll be discussing the latest features added to SOLIDWORKS 2013 simulation. The first topic for the day will be incremental meshing. Incremental meshing is a method for meshing individual bodies or parts within a model. Incremental meshing can be accomplished by accessing the Parts menu within the SOLIDWORKS Feature Manager, right-clicking the part or body, and selecting the Create Mesh option. Create Mesh option opens up a Mesh Feature Manager, which allows you to find the mesh, either finer or coarser. Upon selecting to create the mesh, or the green checkmark icon, you're presented with a dialog box which allows you to either add the mesh control or simply meshes the body. Upon completion of the mesh, notice that the mesh is shown. Only bodies or parts that have been meshed will show in the graphics area. The next feature we'll be discussing today in SOLIDWORKS simulation is the feature added in 2013 called submodeling. Submodeling is the ability to take individual bodies from your main simulation and create a secondary submodel. To create the simulation, simply right-click on the name of the study in the Study Manager and select the option for Create Submodel Study. Upon creation of the submodel study, you'll notice that you get presented with a Feature Manager, which allows you to select the parts with a checkmark box, or you can select the parts within the model graphics area. Once you've selected all the parts that you desire in your submodel, simply click the green check mark. Notice that SOLIDWORKS goes through a number of iterations in order to create your submodel. Once a submodel has been established, you will notice that in your Fixtures folder, SOLIDWORKS has predefined a number of fixtures based on the study setup from the original model. The next feature we have for SOLIDWORKS 2013 is the added ability to view reaction forces and torques on beam elements. So here I have a cantilever I-beam. Notice that one joint is fixed, and the other joint has a force pointed in the negative y direction. We also have gravity acting on this beam in the negative y direction. Notice that this is meshed as a beam element as denoted by the beam icon in the cut list. In order to list the resultant forces, right-click on the results folder and select List Result Forces. Once the dialog box for resultant forces appears, you'll notice that the only option for selection is a joint. In order to see resultant forces, the joint must be a fixed joint. In this case, I will select the fixed joint and select Update. Notice the update inserts a symbol notating the torque on the model and the force placed on the model at the specified joint. To continue in SOLIDWORKS Simulation 2013, we see improvements to the interference detection. As you can see here in the model, I clearly have interference in between two of the faces. The interference detection method is found using the contact set generation. For the purpose of the study, I will use the automatically find contact sets, and I'll use the sub-option for Find Shell Edge Solid Shell Face Pairs. Selecting the shell element and the solid element, I then click Find Contact Sets. Notice in the upper left-hand corner, we get a message which states that interference has been detected. In order to view the interference, we can scroll down and we see the option for interfering faces. Opening the dialog and selecting the options available will show us which faces are experiencing interference. Some of the greatest improvements in SOLIDWORKS 2013 is the ability to quickly create contact sets between shell elements and beams and shell elements and solid elements. Create contact sets as you normally would, right-clicking the contact set and selecting the option for Contact Set. For this demonstration, I'll use the Automatically Find Contact Sets, and again the sub-option for Find Shell Edge Solid Shell Face Pairs. This allows me to select two entities in the model and select the option for Find Contact Set. Notice I have the option to create a contact set 6. Clicking on the plus will insert that contact set into my model. To interrogate this, I'll right-click it, Edit Definition. You can see that the edge was selected of the shell and the face of the solid. The next contact set available in SOLIDWORKS 2013 is the option for Beam to Shell Edge. So notice I use the option for Bonded, and I change the first option to be the beam element. Selecting the structural member for the blue box, and then tabbing to the pink box and selecting the edge of the shell element. The icon representing the shell to beam element interface is notated to the left of the contact. SOLIDWORKS 2013 also introduced the ability to create factor of safety plots for specific elements. You can accomplish this by right-clicking the results folder of a completed study and selecting the factor of safety plot. Notice in the dialog box you have the option for all or selected bodies. With the selected bodies, you can select either from the graphics area or from the feature tree within SOLIDWORKS graphics area. You then either have the option to complete the factor of safety or move along to the next option where you're able to change your multiplication factor, and finally where you're able to change the safety distribution. Completing the study will show you a factor of safety model for only the selected elements which have been defined in the safety plot. Similar plots can be created for stress plots, displacement plots, and each of the other plots by defining the plot and then within the feature manager selecting on the advanced options and utilizing the checkbox for show plot on selected items only. The same principle applies. Select the parts or faces in which you're interested in seeing the associated plot. Also available in SOLIDWORKS 2013 is the ability to render shell thickness in simulation studies. The render shell thickness option can be toggled by accessing a plot, right-selecting the plot and selecting the edit definition. Within the advanced options, we see we have the option for render shell thickness in 3D. This gives us a visual representation of the thickness defined within the shell feature. Next, we have the ability to create transient sensors in nonlinear, dynamic, transient thermal, and drop test studies. The transient sensor can be created by accessing the Evaluate tab and selecting the icon for sensor. Within the Sensor Feature Manager, change the sensor type to simulation data, and within the data quantity, specify the data of interest. The final option within the sensor properties allows you to create the sensor for across all steps, at specified plot steps, or transient. Adding the sensor will insert the transient sensor into the feature manager within the model itself under the sensor folder. The next feature, storing simulation results. You now have the ability to control whether or not SOLIDWORKS stores the stress and strain results for a given study. This feature can be accessed within the simulation feature manager, right-selecting the new option, Result Options. Within the Result Options feature manager, you have an option for quantities to save into file. Toggling the option for stresses and strains will save the stresses and strains calculated during the run. It is important to note that with this option disabled, stress plots and strain plots will not be available. In SOLIDWORKS 2013, contact set limits have been removed. Also available in this version of SOLIDWORKS is the ability to add connector folders, the ability to use multiple select to treat as either beam or solids, and the ability not to store stresses and strains. In order to utilize the new ability to create folders within the connections, simply right-click on the connections icon and select the option for Create New Folder. This allows you to name a new folder. To create a contact within this new folder, right-click on the folder and select the option for Contact Set. This brings up the traditional Contact Set feature manager. Notice that as I complete the contact is actually added within the legs folder. Next, we see the ability to select multiple bodies or parts, and we have the option to treat selected bodies as solids. Notice how each of the bodies was converted from a beam to a solid. SOLIDWORKS 2013 has introduced the ability to define materials as a variable within the design studies. This can be done by accessing a design study, selecting the variables, utilizing the Add Parameter option. Once the dialog box appears, name the variable and select the category for material. Notice that the material can be body specific. Simply check or uncheck the boxes for the bodies you're interested in. Once you click OK, notice that material has been added under variables. You now have the option to select materials. Once you've defined all your materials, select the Run icon, and the design study will run through multiple iterations of the previously defined study with the newly defined materials. As a review to what's new in SOLIDWORKS Simulation 2013, we've learned about submodeling, incremental meshing, the improvements to shells, including defining solid shell contact set and shell to beam contact set, factor of safety on selected bodies, defining result plots only on selected entities, a visual representation of the reaction forces on beam joints, and a number of interface improvements. Thank you for watching this DDI CAD cast featuring SOLIDWORKS Simulation.